How's it going, everybody? In this video, we're going to take a look at our next DMVPN topic, which is probably one of the more complicated ways of looking at it, which is going to be a dual hub, dual cloud design for phase 3. We're going to take a lot of the same approaches that we took a look at in the dual hub, single cloud design, but we're going to be taking a look at it from the perspective of two different tunnels, two different subnets, two different crypto configurations. So this is going to get a little bit more complicated because of the fact that we are dealing with a scenario where we only have one egress interface. So we're going to have to get a little interesting with our setup. We don't have two different transports. We don't have two internet circuits. It'll be okay for the hubs, but for the spoke side, it's going to get a little interesting to figure out how to get everything to work the way that we need it to, because when you are tying two tunnels or two ESPSAs that are going outbound and two that are coming inbound, you need to have some way of providing separation. So we're going to take a look at a couple of examples of how you can overcome that and go from there. So with that being said, we're first going to configure, we already have one tunnel up, right? We're actually going to go to CSR2, and I'm going to basically do show IP interface brief. We're going to say no interface tunnel 100. I'm just going to take this down because we don't need that many connections to primary hubs for this example to work. We're going to create a separate tunnel. I'm going to go and I'm going to type interface tunnel 200. Tunnel source is going to be gig 1. The tunnel mode will be G or E multipoint. The IP address will be 10.1.200.2/24. The IP NHRP map multicast dynamic is going to come into play. The IP NHRP network ID is going to be 200. The tunnel key will be 200, and things like that. So that's pretty much one of the key functionalities that we're going to need to go under. So do show run interface tunnel 200, and we have pretty much everything squared away, and IP NHRP authentication is going to be Cisco. So we have all that. Now I'm going to go to CSR4, and I'm going to take the configuration that we have for interface tunnel 100, and I'm going to mirror it minus a couple of little details. So for example, what I'm going to do is I'm going to come down here, and I'm going to copy this config in like so, except for the tunnel protection. I'm going to get it up and running first, and there we go. And now we can come down here and do this. I'm actually going to config t interface tunnel 100, no any IP NHRP network next hop server to CSR2. I'm going to take that down, and then do show run interface tunnel 100. Take that config like so, and like this. So there we have that. So now what we are going to do is we're going to change some things around. I'm going to actually use this syntax right here. I'm going to pull these three lines of code out, this one, and this one. I'm going to type in the IP NHRP network ID. ID is going to be 200. And then the command I'm going to use is going to be that, but it's going to be 200.2. So that's going to be the first configuration step that I step into. This is going to be that, and that's going to be that. And so there we have that. And I'm also going to do my EIGRP config. So let's go ahead and bring it into play here as well. And we're going to go in here and say that I'm going to pull this AF interface stuff out, and then the network command is going to be network of 10.1.200.00.0.255. And we're going to grab this. That's going to be the first config. Drop that onto this guy. We're going to right click and paste that in. And we have a tunnel up. So now CSR2 should have a show DMVPN. Momentarily we will have it anyway. Let's make sure that everything's lining up. Show interface tunnel 200, network ID 200, tunnel key 200. Let's double check the config, do show run interface. Or you know what, I didn't turn IKEv1 on here. Show run section. Yeah, let me go do that real quick. Let me go modify this real quickly. And then we will do that, but before we can do that, we need to tell it do show run interface tunnel 200, and we have to give it a, let's see, authentication Cisco, all that looks right. So why is that not appearing? Do show run interface tunnel 200. All that looks right. So why is that not appearing? Authentication Cisco. Let's just double check CSR3, make sure I haven't missed anything. Show run interface tunnel 100. Let me go ahead and interface tunnel 100, no shut it. One thing that I will do on 2 is interface tunnel 200 IP NHRP redirect, but that's not going to make much of a difference here. So let me just do a show DMVPN. Yeah, see, it's not triggering for whatever reason. Now this could be a number of different scenarios that could be coming into play here. Show run. It wouldn't be a crypto map issue, tunnel or IKEv1. Oh yeah, it would be. Let's remove this real quick. And then interface tunnel. Let's see. Interface tunnel 200. Shut it down. And see if I can't get it to trigger now. We'll type in no shut. Do show run interface IKEv1. Okay, nothing's there. Let's take a look at 2 and show DMVPN. Okay, it's not receiving anything. Now, what could be preventing us is, let's do a show run, or it wouldn't be a crypto-based config because we don't have the crypto profile associated to it. And neither is CSR4. Do show run interface tunnel 200. We don't have anything applied for that. So it doesn't make a ton of sense as to why this is happening when it shouldn't be. So let me just do a debug NHRP packet. Interface tunnel 200. Let's go ahead and shut it down. And see if we can't get this to trigger. Let's go ahead and no shut it. Tunnel is up. Why is this not working? Show run interface IKEv1. Nothing is there. Show IP route. Let's ping 21.0.0.2. Okay, we can ping that, no problem. The MBMA interface is set up correctly. I know all this is correct. Why is it not forming? So let me figure this out and I'll bring you guys back in. Okay, so I realized what the problem was. The tunnel key is wrong on this side. So let's go ahead and mop that to 200. And 2 should, okay, 2's up and running now. The tunnel key was wrong. So I self-injected troubleshooting problems, but that's okay. I overlooked this aspect of it. No big deal. It does happen, so we want to do .5 for router 5. Copy and paste that in onto CSR2, or I'm sorry, CSR5. That should come up relatively easily. And then 6 will be the same thing. So we just .6, and we will grab that line of config, go over to CSR6, and drop that in. We should form an adjacency. So now we've, at this point in time, we'll have connectivity with all these locations. We're going to have every hub is going to have a single tunnel. Every spoke will have 2 tunnels, 1 to each hub. So if we do show IP interface brief, we'll have 2 tunnels, and we'll have show DMVPN. We will have 2 sets of configuration. Now the thing that we need to focus on now, if we look at the show IP route, we're going to have equal cost multipath to all of the branch, or from the spoke to the hub, and on the hub, if we look at something like CSR7, do a show IP route, we should have equal cost routes to all of the spoke locations as well. And you can see that coming across. We have 2 and 3 are advertising both. This becomes a situation of contention. Now let's go ahead and add cryptography to this, because it's going to definitely be necessary as we move forward. So let's go ahead and figure that piece out next. So we're going to undebug all, and I'm going to go to global config do show run interface tunnel 100, or I'm sorry, 200. We don't have any cryptography here. We're going to put it on. We're going to look at take this. The problem we're going to run into now is if you share the same profile in the same ESP configuration, so the same transform set that's called from the same profile that's associated to the same tunnel, it's not that big of a deal on the hub side because there's only 1 tunnel. On the spoke side is where this becomes a problem. So I'm literally just going to take this config right here. I'm going to drop it onto CSR2, do show run section crypto. I have the profile configured, so interface tunnel 200, and I'll just dump this config right there. That'll enable crypto, and that will actually take down our adjacencies 2, 4, 5, and 6. Now, this is where the problem we're going to run into. The problem we're going to run into is we're going to have connectivity. Do show run interface tunnel 100, tunnel 200. We're getting do show run section EIGRP. Are we getting that across the board? We are. Okay. Interesting. Okay, we have different network IDs though, so it should be two different configurations. So this is a weird problem. So let's take a look at this. Do show run interface tunnel 100 and tunnel 200. Let's look at this a little bit. Why do I feel like I have more things going? Oh, you know why? Because I'm using less config on 1 tunnel than I am in the other. Is blocked. Neighbor 10.1.200 tunnel 100 is blocked. Not uncommon subnet is. Do show. This is not pointing towards 100. Well, that's kind of a unique situation because if this one's giving me tunnel, we're getting uncommon. Oh, I shouldn't have done that. So we're getting uncommon, not uncommon subnet errors, saying that 200.2 is blocked, not uncommon subnet of 100.5. Do show run interface tunnel 100. And, oh, you know why? Let me go underneath this guy and remove this config right here. And do the same thing on 6. Show run interface tunnel 100. Let me go ahead and remove that config. Maybe that'll fix the problem. I forgot that was there. So now we should no longer have a problem, theoretically speaking. Do show run interface tunnel 100. Yeah, so that should go away now. It was weird that it was showing up from the get-go, but we still have a problem with the connection. So let's resolve this issue first. The issue that we're running into, so do undebug all. The issue that we're going to run into now is we have two cryptography scenarios, or sorry, setups, where we have 4, 5, and 6 that need to be configured with cryptography in order for them to work the way that they need to. So if we look at tunnel 200, we don't have the profile set. So if we go back to interface 200, and we take this command right here, and we apply it to here, we're going to get this all tunnel interfaces having the same tunnel source, same tunnel destination for point to point, and the same IPsec profile must be configured with a shared keyword. So what I'm going to go do is on interface tunnel 100, I'm going to go type in the tunnel protection. I'm going to say shared. Okay, I'm going to do that, and then 200. Same thing. So now, when I do that, now we see that the adjacency goes down. Hopefully it'll recover. We'll take a look at this here in just a minute. CSR 5. We'll type in interface tunnel 100. The tunnel protection IPsec profile will be shared. That turns it off and turns it back on, and then we go underneath 200, and then we apply it. So 3 goes down, 2 comes up. So let's look at CSR 6. Interface tunnel 100, do show run interface tunnel 100. We're going to type in this command right here, and we're going to say shared. And then we're going to wait for the syslog message to trigger. And then we're going to go to interface 200 and apply that. Do show IP interface brief. Do show run interface tunnel 100. So let's take a look at 4. Okay, so both tunnels are up. Okay, so we do a show IP interface brief. Both tunnels are up. Show IP EIGRP neighbors. Both adjacencies are up. Show crypto ISA SA. Both connections are up from a phase 1 perspective. Show crypto IPsec SA pipe include peer and PKTS. And we have 3 and 2, and they're both sending traffic. We're great. That's exactly what we want to see. If we do a show IP route, we have equal cost multipath. Great, it's working. So what's the delimiting factor? Or I should say, what's the defining, whatever you want to call it. Show run interface tunnel 100. You have to add on the shared command so that they share the same source, so that they have the same, they're leveraging the same cryptography information. So you can scale this out. Now here's where it gets more interesting. We took a look at CSR 7. We look at the show IP route. For all the traffic that's coming from the spokes to the hub, we see that we've got eCMP. For all the traffic that is going on the spoke side, we'll do a show IP route VRF star. We should see routes from everybody. So all of the hub locations, or I'm sorry, that won't be the case. This will be a, so in this particular case, it's hub side only for in our use case, and we can see that because the way that we've got this stuff set up. So let me explain what I mean by this. Go ahead and minimize this. So when we look at CSR7, we have all the traffic coming from the spokes, okay? All the traffic coming from the spokes that is being learned by CSR2 and CSR3 are being learned, and we can see next top IP addresses of 172.16.1.2 and 3, CSR2 and CSR3 respectively. Same thing with the 172.24, 25, and 26, and the 192.168, 40, 50, and 60. All that stuff still applies. On the spoke side, on CSR8, we're not seeing that. We're not seeing ECMP routes. We're seeing a single connection because we only have a single connection coming down. So think of this like a branch office that's got a single router at it that terminates an internet circuit, but it's logically configured with two different tunnels, one going to one hub, one going to another hub, but two different subnets. In order for us to understand this, we have to go back to the terminating router, so CSR 4, 5, and 6, show IP route. If I could type, we're going to see ECMP here, right? Now, this is where you have to make a decision based off of what's going on. You have to make the decision of do we ECMP route the traffic? So we go back to CSR 8, and do we do a trace route, for example, trace route VRF S4 to 10.1.0.7, sourcing from loopback 172.24.0 numerically, and then try to ride it via CSR3 over the path, and then now we're ECMP load balancing it. We keep trying to do that, and now you can see it's oscillating back and forth. We keep doing that, and now it's load balancing. It's doing what its job is to do. However, we did cheat a little bit in the previous video, and we enabled a little bit of additional load balancing. We're actually taking and modifying CSR4. If we do a show run section Ceph, we added in here include ports. So we're taking a look at the source and destination traffic at the layer 4 level. We're saying, okay, take the port. So every time you send a trace route, it's going to have a slightly different port numbering associated to it. So that's going to change how the router is going to forward the traffic. If we do a show IPsec to, let's say, 10.1.0.0 internally, it's going to load balance back and forth, which is what we want it to do, which is happening right here. We have to 3 to 2 and 3 to 2 to 3 and 2 and 3 back to 2. So it is load balancing the way we want it to. If we were to change this up a little bit and go from go S5 to from 172.250, we should polarize. Right? We're not including the additional traffic to pulling ourselves towards CSR2. So this will beg the question from a design perspective, which way do you want to send your traffic? Do you want to send it all over one particular tunnel, or do you want to send it over multiple tunnels and try to load balance ECMP wise? The choice is up to you. No one can make that decision for you. Now, one thing that we're cheating on here a little bit on CSR2, if we look at this from this perspective, in show run section EIGRP, we don't have split horizon disabled on CSR2 for EIGRP over those tunnels. So that's one of those situations where you have to take into consideration, do you try to go back to the single cloud dual hub design and use longest match routing, or do we take something a little bit similar design and say, you know what, we're going to make one tunnel less preferred than the other in the event that that hub goes down, then we prefer the other tunnel. So the idea would be on the spoke and on the hub, we would have to go to the interface level on an EIGRP, and we'd have to bump up the delay on the tunnel interface and say, you know what, I want to make this a delay of 10,000 on, say, tunnel 200. So we're preferring CSR3, not CSR2, but we're still going to have that as a backup route. It's going to become a feasible successor. So what we end up doing at that point is we have to go through on the hub side and do the same thing. We bump up the routing on CSR2 to be way higher than CSR3, because we don't want to have asymmetric routing. We don't want to be going out, say, CSR4 over tunnel 100 to CSR3, hitting CSR7 to simulate something behind the cores, and then being forwarded back out CSR2 back to CSR4. We don't want to have a looping transition. We don't want to have that. We want to have symmetric routing designs whenever we can, because that's going to give us the most optimal user experience for applications, right? At the end of the day, users don't give two craps whether we have some sort of fancy routing design or not. They want to make sure that when they open up an application, that stuff works. They don't care what we do. If it doesn't work, they complain. We have to go fix it. So to keep your sanity, keep things simple. So I recommend that we take the tunnel interfaces on the hub and the spoke, we bump up tunnel 200 to be a higher delay, so it's less preferred. And then in the event that something happens on the hub side or the spoke side, primarily the hub, because that's what you're trying to build, and you're trying to build in redundancy for the hub. So let's actually go do that. On here, we're going to type in router EIGRP VPN address family IPv4 autonomous system 100, and we're going to type in AF interface tunnel 200, and underneath here we would specify the, it's not underneath here? I could have thought it was underneath here. I don't see the metric option. Maybe it's not. That's weird. Hold time. Maybe, oh, it's underneath the interface itself, 200. The delay, there we go. That's my fault. So we'll make it something really high, like 100,000. It's going to be tens of microseconds. So we do something like that, and then once we do that, then we go back to CSR7, hit the up arrow. Now we're going to polarize just towards CSR3. If we do a show IP EIGRP topology, we're still going to have all those prefixes in the routing table, right? They're still going to be learned by CSR2. We do show IP route. We're still going to be learning all those routes, but our metric is going to be way, way, way higher for traffic coming in over the tunnel versus CSR3, which is going to be way less. So then we would just go to CSR4, interface tunnel 200, type in delay of like 100,000, for example, do show history, and we just bump this up, do show IP route. So now we're preferring the path towards CSR3. We go to CSR5, do the same thing, do show IP route. We're polarizing, go here, do show IP route. Now we're we're not polarizing, now we are. And CSR6, and then we go there, do show IP route, and everything is copacetic now. And these are the things you'll have to think about when you start getting into more complicated designs. Now, could you do the other mechanism where you do longer match routing? I mean, sure, you could attempt to do that, but that means you'd have to do longest match routing both ways. Where before, we only had a dual hub with a single cloud, so we were having on the spoke side, on the hub side, we had two ways to get down to the spokes. We could ride over each hub over the tunnel down to the spoke. Here we have two different ways from each side. So you could do longest match routing each way, you could do longest match routing each way. Which way's better? That's your call. All I'm trying to do is show you a couple different ways that you could solve the problem. and say, you know what, let's modify the delay. Let's go and do a summary address on this one, not a summary address on this one. Longest match routing is a determining factor. It's up to you. I just want to provide you with as many ideas as I can. And if anybody has any ideas and they want to throw them in the comment section below, be my guest. I don't have all the answers. I just have what I know from what I understand from a routing perspective. Now this is straight EIGRP. We haven't touched BGP with DMVPN yet, and I'm probably going to do so, but we'll see exactly how that plays out. So we'll see exactly how that would come into play. But then we're just playing with different routing protocols, and then it becomes an enterprise routing specifically versus a security. But regardless of how you cut it, in order for this particular solution to come into play, we need to solve routing first, then cryptography works. But we really don't have a routing problem, right? What we are trying to prevent are problems in the routing design from roaring their ugly heads. We definitely don't want something popping up in the middle of the night and we end up getting a phone call at 4 a.m. and people going, I can't reach this, I can't reach that. You want to avoid those situations at all, completely. So that's where I'm at with that. If you have any questions, leave a comment in the comment section below. Until next time, guys, thank you so much for stopping by and hanging out with me in this video. Until next time, take it easy.